Good morning, class. Today we're in Unit 6, Lesson 10, different options for solving one equation. So our goal today, let's think about which way is easier when we solve equations with parentheses. So here we're going to start off with our classwork. Right here, obviously it's written in red. So our first option is to divide first. I compare that to like going one-on-one in a basketball game, where to distribute first is like passing to your teammate when open. As we work through today's lesson, both of these are going to be great options, and depending on the equation, one of them is going to be easier than the other. Now, if you have a personal preference that you like to use each time, go ahead and stick with that method. However, I'm going to show you the difference between the two right now before we dive into the lesson. So first, we could divide by 2. That's like going one-on-one. So if we divide both sides by 2, remembering our golden rule of algebra, what you do to one side, you must do to the other. So now we got 28 divided by 2. The 2's cross each other out. Well, 28 divided by 2 is 14. Now we could drop the parentheses, and we have x plus 2 equals 14. Well, now the opposite of adding 2 is subtracting 2. Those cross each other out. Do it to the other side, and we find out that x equals 12. So that was dividing first. Now let's look at what it does to distribute first, or what it means to distribute first. So that's like passing to a teammate, just like Magic Johnson, about to pass it back to Eddie Jones right there. So we're going to take this 2 and we're going to multiply it out to what we have in the parentheses. So 2 times x will give us 2x. Well, 2 times 2 equals 4. So now we have 2x plus 4 equals 28. From there, we have that extra 4, or we're adding 4 to 2x, so we need to do the opposite, which is subtract 4. Well, we do it to both sides, and now we have 28 minus 4, and we get 24 is equal to 2x. From here, we have 2 x's, so we need to divide by 2 to see what 1x would equal. Boom. And now we do it to the other side, so 24 divided by 2 equals 12. So x equals 12. In both cases, we see here that x is equal to 12. One method was to divide first, which is what we did right here. And then the other method was to distribute first, which means to take that number in front of the parentheses and multiply it to each variable or each number within the parentheses. So then we end up with 2x plus 4 once we distribute. Now let's go ahead and dive. Here we have Lesson 10, Activity 1, Algebra Talk. Solve each equation. Now, if we were in class, you'd have 2 minutes individually with about 2 to 3 minutes with a partner or your group to discuss your methods, and then we'd go over it as a class. So I'm going to read each of these problems out loud, and then I'd like for you to pause the video, think about how to solve each of these, and then answer the sentence frames down below. So the sentence frame asks, what was your strategy to solve each problem? I'll need to correct that later on. But the first one first, I blank because blank. Next, I blank because of blank. Then I blank because of blank. Now, we just talked about dividing first or distributing first. So whatever method you feel more comfortable with, or whichever one's easier for you to do, go ahead and try it out, or try out both methods and decide which one you like better. So our first problem here is 100 times x minus 3 equals 1,000. Next, we have 500 parenthesis x minus 3 equals 5,000. Third, we have 0.03 parenthesis x minus 3 equals 0.3. Then we have 0.72 parenthesis x plus 2 equals 7.2, And lastly, we get into some fractions. 1/7 parenthesis x plus 2 equals 10 over 7. So if you're going to use our methods, you might have to use keep, change, flip. But go ahead and pause the video right now and try to work those out, please. Now that you've tried each problem and your methods on each of these, I'm going to go ahead and try both strategies with each problem. So first I'm going to divide, and we're going to take that 100 that's multiplied by the x minus 3 in our parentheses to get 1,000, and we're going to divide it off the left side. So then now we're just left with our parentheses. Well, we have 1,000 divided by 100. We get 10 from that. And now we're left with x minus 3 equals 10. Well, the opposite of adding 3 or subtracting 3 is to add 3. Cancels those out. We have to add 3 to 10, which we get as 13. So x equals 13 for this. Now, we always want to double check our work. So if I go 13 minus 3 in parentheses there, and we multiply it by 100, well, first I need 13 minus 3, which equals 10, and I'm multiplying that out by 100, and I find out that 100 times 10 equals 1,000. So we know that problem is true. Now let's go ahead and look at the 500. In parentheses, we have x minus 3 and it equals 5,000. So our first thing is to divide by 500 on both sides. Those cross out. 5,000 divided by 500 equals 10. So now we have x minus 3 equals 10. The opposite of subtracting 3 is adding 3. So those eliminate each other. But golden rule of algebra, we have to do it to both sides. So 10 plus 3 equals 13, which gives us x equals 13. Now we're not done because we need to double check our work. So we go 500 times 13 minus 3 equals 5,000. And we see here that 13 minus 3 equals 10. Multiply that by 500, and our statement is true because 500 times 10 equals 5,000. Now we come over to our decimals, and we have our 0.03, and it's multiplied by x minus 3, and we're going to take that 0.03 and divide it out from the left side. So that's going to cross out, but when we do this, we got 0.03, and that actually equals 10. And now we have x minus 3 equals 10. And you could see that there's a pattern developing here that we're ending up with x minus 3 equals 10 every time that we divide first. So as you've seen in the other equations, we're going to have to take x plus 3 to cross those out, do it to the other side of the equation. 10 plus 3 equals 13, so x equals 13. And when we multiply it out, we get 0.03. We got 13 minus 3, and that equals 10. 0.03 times 10 gives us what we're looking for of 0.3. Now when we come over here, I'm going to let you take a guess as to what x might be. But if we take our 7.2 and divide it by our 0.72, we're going to get 10 again. So we take our 0.72, divide it out, do the same thing to the other side, golden rule of algebra. Boom, we get 10 right here. And now the parentheses drop. Well, we have x plus 2 equals 10. Now this is slightly different than what we had going in the previous three problems. X plus 2, well, the opposite of adding 2 is subtracting 2, crosses that out. Well, 10 minus 2 now equals 8. So we get x equals 8. But we're not done because we want to check our work. So in this case here, we have 0.72 times 8 plus 2. Well, that equals 10, and 0.72 times 10 gives us what we're looking for of 7.2. Now here, we're dealing with our fractions, and we need to use one of our fraction strategies, which is keep, change, flip when we divide with fractions. So we divide 1/7 out of both sides. That crosses each other out. So it would look like this, divided by 1/7. However, we know we need to do keep, change, flip. 10 divided by 7 times 7 over 1 provides us with 70, because 10 times 7 equals 70. 7 times 1 is 7. We could obviously reduce that. 70 divided by 7. We could just cross out our, well, divided by 7 equals 10 as we reduce it, or 10 over 1 in that case. But that also reduces down to 10. So as we're running out of space here, we end up with 7x plus 2 equals 10 over 1, which is just 10. Now, as we come over, we need to subtract 2 from both sides. Boom, that crosses out. Subtract our 2. We get x equals 8. And if we want to double check our work, we're going to input 8 right there to see what happens, all right? So I'm going to rewrite it over here. We got 1/7 times 8 plus 2, and that should equal 10 over 7. Well, we get these two added together, we get 10. Well, when we want to multiply a whole number by a fraction, we simply put 1 underneath our whole number, and then we can multiply across because it's just simple multiplication. We don't need to find a common denominator. We don't need to do keep, change, flip. It's just simply multiplying across. So 1 times 10 equals 10, and then 7 times 1 equals 7. Our answer proves that our equation is true when our solution is 8. Next, I'll go ahead and show you how to distribute first, but I wanted to show you how to divide first. So the next method that I'm going to show you is going to be to distribute first. So let's take a look at our first equation. We have 100 times x minus 3 in parentheses equals 1,000. So to distribute first, that's like passing to one of our teammates. So we're going to take our 100, we're going to multiply it by x, and then we're also going to multiply it by a -3. So 100 times x gives us 100x, and then we have 100 times a -3, which gives us a -300, and of course that equals 1,000. From here, we need to do the opposite of subtracting 300, which is to add 300. So we add our 300 to eliminate it from the left side of the equation. Following the golden rule of algebra, we do it to the other side as well. So we add 300, and we get our new equation, which would be 100x equals 1,300, or 1,300. And then we're going to divide both sides by 100, and we get x equals 13. Now we're going to repeat that process of distributing first for 500 times x minus 3 in parentheses equals 5,000. So we're going to take our 500, multiply it by x, then we're going to take our 500 and multiply it by -3. So 500 times x is going to be 500x. I'm going to multiply it by -3, And of course we get negative 1,500 or 1,500, and it is equal to 5,000. Now the opposite of subtracting would be adding. So we're going to add our 1,500 to both sides. We're going to end up with the equation of 500x equals 6,500. And then of course, the opposite of multiplying by 500 is dividing by 500. Cross that out, divide this by 500 as well. And you can almost cross out these zeros. So 65 divided by 5 is 13. X equals 13. As we move over, we're going to repeat this process of distributing first. So we have our 0.03, so that's going to multiply out right here, give us 0.03x. And of course we need to multiply our -3 times our 0.03, and we're going to get a negative 0.09, and it equals 0.3. Now the opposite of subtracting is going to be adding, so we're going to add that over here, 0.09. We cross that out, we'll add it over here, 0.09, and so now we get our equation of 0.03x equals 0.39. Then we're going to divide both sides by 0.03. So boom, 0.03 crosses out, divide this by 0.03. And we get x equals 13. You can almost do 39 divided by 3. And 3 times 39, double check your work real quickly, equals 39. So 3 times 13 equals 39, and our x works out for that equation. Next, we have 0.72x plus 2 equals 7.2. The x plus 2 are in parentheses, so we're going to distribute first. Get right here with 0.72x. We add, but we got to multiply that out first. And we get 0.72 times a positive 2 gives us 1.44. That equals 7.2. The opposite of adding 1.44 is subtracting it. So we're going to subtract from both sides. 4 and 7.2 minus 1.44 gives us 5.76, and that's equal to 0.72x. We brought that over because boom, right there. Now divide both sides by 0.72, cross out. Divided by 0.72, and we get x equals 8. And lastly, we have our 1/7 times a parenthesis of x plus 2 equals 10 over 7. I'm going to go ahead and erase this. Whoops. Some of our work here, so that way we could get a little bit more workspace. So again, go ahead and decide which method you like first, or which method's easier for you. Practice that more consistently, whether you like to distribute or divide first. So we've already done the division. Now we're going to go ahead and distribute. So we get 1/7 x. when we multiply these two, we get 1 over 7x. And then, of course, we need to multiply 1/7 by 2. Well, we turn it to 2 over 1. Well, 2 times 1 is 2. 7 times 1 is 7. That is equal to 10/7. Well, the opposite of adding 2/7 is subtracting it. Those cross out. And then we're going to subtract 2/7 here. The key is that we have a common denominator. So 10 minus 2 equals 8. And then our 7 remains the same. Well, now we have the equation because we're going to bring over our 1/7 x over here. So that equals 1/7 x. That means we have to divide. So we could divide both sides by 1/7. That crosses out. So we could put 8 over 7 divided by 1/7. We need to use keep change flip right here. So we're going to change our division to a multiplication, and we're going to flip this to now have 7 over 1. And of course we have 8 times 7, which is 56. And 7 times 1 is 7. Well, 56 divided by 7 reduces down to 8. And we have x equals 8. So there you have it. You have your first time we went through, we had division. This time I've shown you each step with distributing first. Now what I'd like for you to do is, what was your strategy and what you did first, what you did second, and what you did third. So you're either going to write that you divided first, or you could say you distributed first. Whatever method that you preferred, just go ahead. I divided first because next I added or subtracted to isolate the variable, and tell us why you did that. And then, lastly, you divided by the number of x's that we had to isolate exactly what x is and what our solution is. After finishing 10.1, we're going to move on to 10.2, which is analyzing solution methods. If we were in class, you'd have 3 minutes individually, and then we'd have 5 or so minutes to work with a partner or a group, and then we'd cover it or review it for about 5 minutes as a class. Well, here we have 3 students, each attempted to solve the equation 2 parentheses x minus 9 equals 10, but got different solutions. Here are their methods. Do you agree with any of their methods and why? It's important that you explain the why using our sentence frames that I provided below each method. So we have method 1 right here, and then we're going to have to go down to the next page to look at method 2 and method 3 that were presented. So go ahead, pause the video right now, scroll back up to our first method presented, and tell me if Noah had a correct solution and why or why not. If you're having a tough time starting off solving or looking at Noah's method, just consider what is a solution. So here you could see a solution to an equation is a variable for or value for a variable that makes an equation true. So when we look here onto the left side, we have 2 plus x equals 4. Well, we need to find what the value of x is. So 2 plus 2 equals 4, so x equals 2. Now, if we look at the example on the right, we have a plus 14 equals 23, and we need to figure out what plus 14 equals 23. In this case, a is 9. So think about what the value for our variable is to make that equation true. Now that you've attempted to see the errors or the correctness in the three methods, let's go ahead and take a look at our first method. Well, our two goals today were to either divide first or to distribute first. So we're either going one-on-one with division, or we're passing it out to our teammates using distribution. And well, Noah here, his first step was to add 9 to each side. So he didn't divide and he didn't distribute. So that makes his error on the very first step right here, because he needed to take care of this 2 outside the parentheses. So he could have distributed, or he could divide it by 2. Unfortunately, he went ahead and added, which is technically the opposite of -9 or subtracting 9. However, he didn't take care of the 2 outside the parentheses first. So that gave him an invalid solution. So when we plug in 19 over 2 into that equation, we get 19 over 2 minus 9 times 2. Well, we have to find a common denominator if we're going to subtract. Well, 9 over 1, we got to multiply that out by 2 in order to get a common denominator. So realistically, we're going to have 2 times 19 over 2 minus 18 over 2, which gives us 2 times 1/2. Well, 2 over 2, because we multiply across here, and that reduces down to 1. Well, our equation is set to equal 10, and we know that 1 is not the correct solution that we're looking for. So in this scenario, we're going to go ahead and disagree, and then we write his name down, Noah, because, and then go ahead and explain that error right here in this step, how we added instead of dividing or distributing right away. So for method 2 presented, we have Elena's method. She has 2, again, times x minus 9 in parentheses equals 10. And she went ahead and applied the distributive property right away. And it actually looks like she did it correctly, as 2 times x is going to equal 2x. And then 2 times -9 is going to equal -18. Now, as we work through it, the first step, or the second step now, is subtract 18 from each side. Now, when we're dealing with opposites, or we're trying to isolate x, when we're subtracting 18 right here, the opposite of 18 would be to add 18. However, she went ahead and subtracted 18 again. That wouldn't isolate that. That would give us a -36 on that side, which would create an unbalanced equation, which we don't want. So unfortunately for Elena, we're going to have to disagree with her method right there, and go ahead, fill in her name right here, and then explain on the second step where she made her mistake within that sentence frame. Another way to prove that her method or her answer for our solution is incorrect is to go ahead and substitute it in for x. So in this case, we'd have 2 times a -4 minus 9 equals something, and then it should equal 10 if it makes the equation true. However, we have a -4. We're going to continue to go further negative with -9, so we're going to have -13. We're going to multiply that by 2, in which case we'd get a -26. And these two don't match up, which means x cannot be -4 to make this equation true. The third method presented was by Andre, and he went ahead and applied the distributive property first. So again, he went ahead and multiplied 2 times x and then multiplied 2 times -9, and he correctly got 2x minus 18 equals 10. And then looking at step number 2, he went ahead and added 18 to both sides, which isolated the x, added that properly to the other side, and then we ended up here with 2x equals 28. Now we have two x's, so we want to find the value of a single x. So in this case, we divide by 2, which he went ahead and did right here. And so 28 divided by 2 equals 14. So far, I have to say we agree with Andre. And go ahead and write his name in right there. Just double check though, let's go ahead and plug in or substitute 14 for x. And we have 2 times 14 minus 9 equals 10, or it should equal 10. 14 minus 9, we have 5. And then multiply it out by 2, and we get 10. Those match up, so we'd have to say Andre took 3 steps. He applied the distributive property, he added 18 to each side, then he divided by 2 to correctly find the solution of 14. Now as we move on to activity 10.3, solution pathways, we'd have 4 minutes as a class to discuss something. We'd go 3 minutes individual time to try to solve for some different solutions. And then we'd have 5 minutes with your group or with pairs, and then we'd talk about it as a class. Well, before we dive in and look at the different equations that we're going to have to solve for, we are going to look and review some of our key ideas of today. So our first one is to divide first. Our next option is to distribute first. Remember, dividing is kind of like going one-on-one, like James Harden's famous for, and distributing first is kind of like passing to a teammate. And the equation that I wanted to review was 3 times parentheses, or x plus 2 in parentheses equals 21. And over here you could see the balance hanger. We have 21 here on the right, and we have 3 boxes of x plus 2 in each one. Now, if we're going to divide first, we're going to come over here, and we're going to divide both sides by 3. So we take care of the 3 right away. Boom, those cross out. We get x plus 2 equals 7. Now we have to do the opposite of adding 2, which is subtracting 2 from both sides. And we drop down to x, and 7 minus 2 equals 5. And we could always double check that, because 5 plus 2 equals 7. And last time I checked, 7 times 3 equals 21. So that one works right there. Now let's see if we could do that a different way. So the different way we could attempt or attack this problem is to distribute first, to try to pass out to some of our teammates. So here we need to multiply 3 by x, that gives us 3x. Then we need to multiply 3 by 2, and we get 6 equals 21. Now in this case, the opposite of adding 6 is subtracting 6 from both sides. Cross those out, and we drop the 3x down, and 21 minus 6 equals 15. And we need to divide by 3 to get rid of the 3 right there. 15 divided by 3 equals 5, so x equals 5. And of course, we could always plug our solution back into the equation and double check, but it matches up with this right here, which we found out earlier. 5 plus 2 equals 7, and 7 times 3 equals 21. And if you weren't sure about those two, we could always come over to the balance hanger and reason out, like we have in previous lessons, how we could solve for x. And if you need to, you could go ahead and refer back to our previous class notes on reviewing balanced hangers. So now as we scroll down, our instructions here are for each equation, try to solve the equation using each method. So one time you're going to try to divide each side first, or then the next time through you're going to try the distributive property first. Some equations are easier to solve by one method than the other. When that is the case, stop doing the harder method and write down the reason you stopped. So as you go through, you're just going to try number one. I'd say let's try to divide first. And then once you get to a certain point, if it's too difficult, you could go ahead and try to distribute. But if dividing works and keeps it simple for you, go ahead and attack that problem as best you can. And then you're going to repeat the process for number 2, 3, 4, and 5. So at this point, go ahead, pause the video, do the best you can. And if you struggle, that's perfectly fine. That's what we want at times. So that way we can find different errors and work on some of our weaknesses. All right, now that you've attempted each problem on your own and hopefully have an idea if you'd like to distribute first or if you'd like to divide first and which one might be better for each equation, really there's no right or wrong answer. So let's go ahead and look at number one. We have 2,000 right here divided or multiplied by x minus 0.03 in parentheses equals 6,000. So at first I'm going to just go ahead, divide 2,000 from each side. That cancels out right there. Divide by 2,000 right here. And I get, well, these all kind of cross out. Well, 6 divided by 2 equals 3. And then I'm left with x minus 0.03 equals 3. Well, the opposite of subtracting 0.03 is to add it. And then once we add it to one side, we need to add it to the other side, 0.03. And we actually end up with x equals 3.03. So that's our answer for number one. And that was just pretty much dividing first and then following our appropriate steps to keep the equation balanced as we found our solution. Here, I'm going to go ahead, try to divide both sides by 2. Well, that's easy there. Well, I really don't like dividing and doing decimals. That's just a preference. Some people may, so you could have continued on with this just for the sake of argument. I'm going to go ahead and stop there and rewrite the equation and distribute first. So 2x plus 1.25 equals 3.5. Now instead of multiplying first, I'm going to distribute, instead of dividing, I'm going to multiply first, which is distributing. So 2 times x gives us 2x, and of course we have 2 times 1.25, and that gives us 2.5. And that leaves us equal to 3.5. Well, that's a lot easier for me in my mind without a calculator workout. So I go 2.5, subtract, or do the opposite of adding. So that crosses out, do it to the other side, and I get 1 is equal to 2x. Well, we know we need to divide by 2 here to isolate, and we get 1/2, or x is equal to 1/2, or you could convert to decimal form and go 0.5. So our answer for number 2 is 1/2. And for me, I preferred to distribute that time instead of divide. Let's go ahead and look at number 3. Now, I'm going to go ahead and just divide first. So I'm going to divide by 1/4. That cancels out right there. Do it to the other side, 1/4. And what is the term or strategy we need to use? And if you're thinking keep, change, flip, that's exactly right. So we're going to keep, change, flip right here. So 4/3 will actually multiply by 4/1. and that will give us 16 over 3. And I know a lot of my students at first see 16 out of 3. They're like, man, I don't like fractions. Let's go ahead and go a different route. I'm going to try to encourage you to stick with this right now. And we're going to have 4x, or 4 plus x, equals 16 over 3. Well, now we need to subtract 4 from both sides. Well, subtracting 4, well, we convert that to a fraction. 4 over 1 is the same as 4 right here, right? Well, we need a common denominator, which is 3. Multiply both sides by, or numerator and denominator by 3, so we technically get 16 over 3 minus 12 over 3, and now we're going to get 4/3. And since we isolated x, we could just drop him down, and that is our answer. So our answer is 4/3, or x equals 4/3. You could also write that, convert it from its improper fraction form to a mixed number, which would be 1 and 1/3. So either one of those will be acceptable in this scenario. Now let's go ahead and look at number 3. I'm going to go ahead and divide first, like we were trying earlier. And we divide -10. Boom, we come over here, -10. Which isn't so bad, but then I get x minus 1.7 equals, well, a negative divided by a negative is a positive, so 3/10, because those cancel each other out right there. Now, this is where you could convert this 1.7 right here into a mixed number, or even into an improper fraction. And the way you would do that would be to put 1 and 7/10, and of course converting that into an improper fraction would be 17 over 10, and you could continue on with this process if you'd like. However, I'm just going to go ahead and say, you know what, I don't want to work with a decimal and a fraction right here, so I'm going to stop and rewrite my equation and try to distribute first. So I'm going to have -10 times x minus 1.7 in parentheses equals -3. Well, I need to multiply out first if I'm distributing, and I get -10x, and a negative times a negative will become a positive, so I'm going to add, or get a positive 17 equals -3. Well, the opposite of adding 17 is to subtract 17. Those cross each other out, and -3 minus -17 is -20. Well, now we have -10x equals -20, and we need to divide both sides by 10, or -10. That isolates x for us, and of course we have -20 divided by a -10, and a negative divided by a negative becomes a positive, so our x is equal to 2. Right there. Cross those out. 2 over 1 is just 2. So that's our answer for number 4, and I'm going to say I preferred the distributive method better. Over here, I went ahead and said I like the dividing method better. Now, right here for number 5, we have 5.4 equals 0.3 times x plus 8 in parentheses. Now, some students might get a little leery because they're flipping the sides in which the variable was on, but ultimately it doesn't matter as long as we could isolate the variable. It doesn't matter if it's on the left side or the right side. As long as we could get x by itself, we'll be able to solve for it. So we're going to go ahead and divide by 0.3 here, and without a calculator, man, it just seems like a lot of work to divide that. Now, some of you are pretty good at long division. It's not a problem. Go ahead and attack that problem the way you want to. But again, for argument's sake, I'm going to go ahead, erase that, and I'm going to distribute first. just simply because I believe it'll be easier on me without a calculator. So again, we're going to have 0.3x, and then we multiply 0.3 times 8, and that is where I get 2.4. And just in case you're wondering how I got that, well, 0.3 times 8, well, 3 times 8 is 24. So we get our 24, but we had one number behind the decimal, so that's why we bumped it up right there into 2.4. Now we have 5.4 equals 0.3x plus 2.4. We're going to subtract the 2.4. Wow, my handwriting is getting sloppy. I apologize about that. Let me clean it up a little bit for you. Minus 2.4. And I need to be able to do that to the other side. And of course, wow, this is horrible over here. So if you happen to make the same mistake of having some sloppy handwriting, I'd appreciate it if you clean it up occasionally. And then we're going to go ahead and subtract 2.4 from the other side because these cross out, keep it balanced. So now I'm left with 3 over here. Well, once I have 3 equals 0.3x, I need to divide both sides by 0.3. And for me, that was a lot easier to do because I know 3 divided by 0.3 equals 10. So right here, boom, that is going to equal 10. So x equals 10. Now, some of you may have preferred using division all the way through or as your first step, and then I went ahead and used, I distributed first, so I'm going to put that as distribute. Now, here in these two sentence frames, if you found that dividing all of them was easier, go ahead and tell me which ones you thought were easier when dividing. And if you thought certain ones were easier to distribute, go ahead and tell me which ones you were. For mine, it looks like I had number 1 and 2 for dividing, and then I had 3. Whoops. Nope. Messed up on that one too. 1 and 3. 1 and 3 for dividing, and then I had 2, 4, and 5 for distributing. Now again, there's really no right or wrong answer as long as you could justify it. I ask that you give me a little bit more detail than what I jotted down here, but that's a quick example for you. Now, as we finish up the lesson, you have your lesson summary that I had asked that you go ahead and read. And it's important to read these because it's going to help expand your math vocabulary. And I know our 8th grade teachers and our teachers at the high school are going to expect you to have that knowledge coming into class. So go ahead, read this as best you can. And if it confuses you at times, that's perfectly fine. But I suggest highlight what you think are some key terms and try to take away what you can from there. And then now we're returning back to our classwork packet. In this right here in red, we have our lesson 10 synthesis. Number 1 that you need to jot down, you don't have to write the question, but jot down these notes in red. So we have, what are 2 main ways we can approach solving equations like the ones we saw today? Well, of course, we could divide first, which is like James Harding going one-on-one right away, or we could distribute first, pass out to our teammates, kind of like Magic Johnson, like we discussed at the beginning of the lesson. Number 2, what kinds of things do we look for to decide which approach is better? Well, there's powers of 10. Sometimes that helps. Operations that result in whole numbers. We don't prefer necessarily to have to work with fractions or with decimals. So if we could get a whole number, that kind of simplifies the process for us. And then, of course, there's moves that will eliminate fractions or decimals. So if we could avoid those at times, it might make our life easier, especially if we don't have a calculator or if there's some time constraints that we're dealing with, like on a test. And then lastly, number 3, how can we check if our answer is a solution to the original equation? Now, I didn't do this in the last activity to help save some time, But prior to that, we substitute our answer for the variable and see if it makes the equation true. So that's what you also need to write down. So if you could add those into your classwork, I'll make sure that once all the classwork gets submitted, I take a picture of it or a screenshot and send it out on Remind. So hopefully if you didn't get it, you weren't sure what should be in there, you could take a look at that, make sure your notes are good, so that way you could be better prepared for the test when we need to study. Now we're going to go ahead and look at our cool down. So in our lesson synthesis, we looked at which one was going to help us solve the equation faster or help us eliminate fractions or decimals, to decide which one was going to be better for us. And our first option was to divide, and our second option was to distribute. So in our cool down for Unit 6, Lesson 10, which is different options for solving one equation, we want to solve each equation and show our work or explain your method. Now, looking at this, I'm looking at 8.88 equals 4.44 parentheses x minus 7. So when I see this, I see that 4.44 and the 8.88. I realize that I multiply that out, I'm going to get 2. But if I divide it, or basically if I divide both sides by 4.44, I will get 2. Because 8.88 divided by 4.44 is 2, and now I have x minus 7 on the other side. Well, we need to add 7 to isolate the variable. That cancels out here. We add 7 over here, and 2 plus 7 equals 9. So x equals 9 right there for our first problem. Now we use division first because we were able to eliminate some of the decimals in this scenario with the whole number right there. Now our second problem is 5 parentheses y plus 2/5 equals negative 13. Well, if I divide by 5 right away, I'm left with fractions on both sides of my equation. And when deciding if I want to divide or distribute, I want to try to eliminate fractions and decimals to make the process simpler for me. Well, and if dividing by 5 doesn't help me eliminate that problem, then let's try to distribute. Well, 5 times y is 5y. And when I multiply 5 times 2/5, I have to convert it into a fraction. Well, 5 times 2 is 10. And then 1 times 5 is 5. And I know that reduces down to 2 over 1, which is technically 2. And that is equal to negative 13. Well, we're adding 2, so we need to subtract 2 right here. And we need to subtract 2 on this side. Well, negative 13 minus negative 2, or minus 2, I should say, is negative 15. And we have 5y over here. Well, we need to isolate y, so we divide by 5. And we need to divide negative 15 by 5. Well, a negative divided by a positive is going to be a negative, and 15 divided by 5 is 3. And we get y equals negative 3. Now, to double check your work on number 1 and 2, you need to go ahead and substitute your answer in for x to see if that works out. And same thing for number 2. Try to go ahead and plug your answer in right there to solve it. All right, that concludes today's lesson. The homework will be up, and if you need any help with that, I ask that you refer to Mr. Morgan's homework help. And if you have more questions in addition to that, go ahead and send me a remind message or message me on Canvas, and I'll get back to you as quickly as I can.